Good afternoon, everyone. Today, inshallah, we will continue our operations on the system, our lectures on the system, linear system of equations. As you know, all the lectures and everything, you will find them on Moodle. Also, I want you to take the quizzes on regular basis. You have plenty of exercises over there, and also you have the recorded vids on Moodle explaining each week work. Also, all the recorded lectures, you will find them on my YouTube, so you should be able to review them easily. I want you to remember that in the previous session, we already we talked about this. It's the classification of a system of equations. And we know that if you have a system of equations, the solution will be between consistent or inconsistent system. The consistent system, which means your system, will have a solution. The inconsistent, it means the system of equations contains a wrong information or not correct, not binded together, okay? Cannot develop a solution. So mainly, if we are trying to solve a system of equation, we are between consistent and inconsistent. In case of consistent solutions, we are between two alternatives. The first of them is to have a consistent independent solution. The other one is consistent dependent solution. The consistent independent, it means you will have just only one solution that will satisfy this set of equations. Okay, the consistent dependent, it means you will have a solution for this set of equations, but it will depend on one of the variables. That's the general, okay, distribution or classification for solving a system of equations. Also, we did explain what's the rank. The rank, it's the number of non-zero rows in the reduced echelon form or in an echelon form. This is the number of non-zero rows. And based on the rank, we can also classify the solution of a system of equations. Okay, so based on a system of equation arrangement, Omar, which is AX equal to B, that's A, which is the coefficient matrix, X, which is the unknown, B is the independent column. We will have if rank A equal the rank of the augmented matrix. Of course, the augmented matrix is really very simple. We mean by the augmented matrix the sum of these two matrices together. So it's matrix A, then matrix B. This is the augmented matrix. So we now know that the rank of A and the rank of the augmented matrix. So still, once more, we are in between solving a system of equation, either consistent or inconsistent. Inconsistent may happen if the rank of A doesn't equal to the rank of the augmented matrix. So the rank of A is different than the rank of the whole matrix. Okay? So there will be no solution. Okay, in order to have a consistent solution, the rank of A matrix should equal to the rank of the augmented. This is the first step. So in both these two steps, R of A is equal to R of the augmented matrix. Both of them equal to each other. But if they are equal to the number of variables, then you will have a consistent independent solution. Okay, if you have the rank of A equal to the rank of the augmented matrix but less than the number of variables, then you will have a consistent dependent solution. This is why it is written here rank of A doesn't equal to n, which is the number of variables. شباب كلامي واضح؟ يبقى تاني الرانك بالعربي الرتبة، رتبة الماتريكس. الرانك هو عدد الصفوف اللي مش بصفار. بيزد على الرانك ده اقدر اعمل كلاسيفيكيشن للحل. يبقى رقم واحد، لو الرانك بتاع الماتريكس الصغيرة مش بيساوي الرانك بتاع الماتريكس الكبيرة، يبقى ده معناه ايه؟ مفيش حل. طب لو التو رانكس equal to each other يبقى في حل. بس التو رانكس I will compare them with the number of variables. لو equal to the number of variables, then you will have consistent independent solution. لو less than the number of variables, you will have infinite number of solutions or consistent dependent solution. These are the main distribution or the various types of solutions against the rank. I would like to solve with you these problems, to go with these problems, in order to see how we use row operations in order to get a solution for each of these systems. Although this slide is still in the by the end of the work of this week, but I prefer to give it to you at the time being. So let's start solving any of these systems using Gauss-Jordan or using the main row operations. Okay, I will start one by one. Let's just give me a second. Okay, so I will write the system and then I will solve it. I will start with this system. This system simply can be put on the form as a matrix form. It can be, the coefficient matrix will be 2 for x1, 3 for x1, and 1 for x1. So this is x1 column. For x2, you will have -1, then 0, then 2. For x3, you will have 3, then you will have +1, then x3 is equal to 3. Those are multiplied by x1, x2, x3. And the result, all of them will equal to 4, 3, and 8. Here is 4, 3, and 8. That's the result. Okay. That's the system of equations that we already had previously. Let's try to solve it using row operations. The first step is to form the augmented matrix. Remark, this is what is called the coefficient matrix. This is the unknown matrix, and that's the result matrix. Okay, so the system is A times X equal to B. What I'm going to do now is to form the augmented matrix. The augmented matrix is really very simple. All I have to do is to put the coefficient matrix, which is 2, 3, 1, -1, 0, and 2. Then 3, 1, 3. Then you have a dotted line. The result, which is 4, 3, 8, which is the right-hand side for each of these equations. How to solve? I will need to reach the reduced echelon form. Do you remember what's the reduced echelon form? The reduced echelon form is to have a unit matrix from this dimension. The echelon form is to have an upper triangular. Now I'm going to reach or to try to use the row operations to change this matrix to be a row, a reduced echelon form. So the first step that we will do at the time being is to focus on the pivot of the first row. What's the pivot of every first row? The element 1, 1, and it should equal to +1. So try to think about the 3 operations that we talked about previously, which are switching rows, if you like, multiplying row by a number and adding it on another row, or simply multiplying a complete row in a certain number in order to get the pivot or to change the pivot value. Here I can simply swap the row 3 instead of row 1. Or I can multiply the last row in -1 and add it on the first row. If I did that, I will change the first row to be positive. I will do it. I will multiply here, I will multiply, getting R1 dash, then UR1, which simply is gonna be multiplying negative R3, multiplying R3 -1, then adding it on R1. That's the result that we will see. That's the new matrix. Okay, -1 plus 2, the result will be +1. -2 plus -1 is gonna be -3. Negative 3 plus 3, the result will be 0. Negative 8 plus 4, so it's gonna be negative 4. Now I succeeded in changing the pivot of the first row to be positive 1.
Okay.
The second step is to force the elements 3 and 1 to become zeros, okay, beneath this pivot. How to do it? I will use one of the row operations that we have, which is multiplying the first row by a number, then adding it, Mr. Ahmed, on the second row. So remark that I need this number to be 0, but it is equal to 3. How to bring the 3 into 0, Omar? I will multiply this pivot in this number, but with opposite sign. So let's multiply. Negative 3 plus 3, the result is 0. Negative 3 times negative 3 is going to be positive 9. Plus 0, it's going to be 9. Do it once more. Negative 3 times 0, 0 plus 1, 1. Negative 3 times negative 4, it's positive 12. Plus 3, so it's going to come up to 15. Please be careful with me. You usually make silly mistakes in algebra. So I want you to follow up with me. Okay, once more, I need this number to be 0. So all I have to do is to multiply this number by the exact same number but with opposite sign. So I will multiply negative 1. Then I will do the addition. Negative 1 plus 1, the result is 0. Negative times negative 3 is positive 3 plus 2, the result is 5. Negative 1 times 0, 0 plus 3, it's going to be 3. Negative times negative 4, it's positive 4 plus 8, so the result will be 12. Now I need to think about something for, first of all, remark that we succeeded in adjusting the first column to be 1 double zeros, as you can see. This is the second row and the third. I'm sorry, the second column and the third column. I will start now with the new matrix. My purpose is to get this pivot equal to positive 1. Then using it to force this element to be 0 and that element also to be 0. So I want you to think of something from the 3 operations to make positive 9 equal to positive 1. Or to change 9 to be positive 1. What to do?
1 over 9.
All?
1 over 9.
Yes, if I multiply by 1 over 9, it's correct. But unfortunately, I will start to act or to deal with fractions all over the place. صح؟ يبقى عندك fractions.
حسن.
Okay, طيب أنا ممكن أفكر في حاجة تانية. Let's multiply the second row by negative 1. Why not? We multiply this row by negative 1. It is accessible and really very easy. One of the row operations. Then I will multiply the last row in positive 2 and then I will add it on the row above it. So R3 times 2 plus R2. Let's do that. تعالى كده جرب. لو أنا ضربت ده في 2 times 5 is gonna be 10. 10 plus negative 9 will be
1.
So it's gonna be 0 and 1. 2 times 3 is gonna be 6. 6 minus 1 is gonna be a 5. Once more, 2 times 2, it's gonna 2 times 12, I'm sorry, it's gonna be 24. 24 minus 15 is gonna be 9. Are we correct? So I multiplied the last row in positive 2 and added them on the second row. معايا يا أحمد؟ لما عملت كده جبت واحد وtried as much as possible to avoid rational numbers in order to make it easier on me in calculations. Okay, once more, I need to change this value. Instead of having a negative 3, I need it to be 0. How to force this number to be 0 using the row operations? I will multiply this row by the same number but with opposite sign. Then I will add them together. So I will multiply Ahmed in mean in 3. So Ahmed, Muhammad in 3. Okay, let's do it. 3 times 0, 0 plus 1, it's gonna be 1. 3 times 1 be 3. With negative 3, it's gonna be 0. 3 times 5 it's 15. Plus 0 it's 15. 3 times 9, 27. 27 minus 4, so it's gonna come up to 23. In a similar manner, I need this number to be 0. So I will multiply all of this row by negative 5. And I will do it step by step. Negative 5 times 0 is equal to 0. Plus 0, 0. Negative 5 plus 5 is going to be 0. Negative 5 times 5, negative 25. Plus 3, so it's going to come up to negative 22. In a similar manner. Multiplying in negative 5, it's going to be negative 40. Plus 12, so it's going to come up to negative 33. Let me check the signs again. I'm multiplying in negative 5, so it's going to be negative 25 plus 3. It's going to be negative 5 times 9 is negative 40 plus 12, so it's going to come up to negative 53. If you remark, I've succeeded in adjusting the second row. I'm sorry, the second column. I will go to the third one to hunt the third column. The pivot must be positive 1. So I will try to change this value to be positive 1. What's the only solution that I have, Ya Omar? Multiplying in negative 1 over 22. Here there is no other options because this is the last row. If you multiply, if the numbers help you to multiply any rows from the above rows in something and adding it on this row, you will destroy these zeros. So if I want to add something, I usually do it from bottom to the above rows. يعني لو انا بضرب في رقم وبجمع بشتغل من تحت لفين؟ لفوق، ما بشتغلش من فوق لتحت. فوق لتحت هيدمر لك الاصفار اللي انت جبتها. طيب يلا الستيب اللي بعده. So once more I will divide on negative 22 or multiply by negative 1 over 22. So it's gonna be 0, 0, 1. Negative 33 on negative 22, it's gonna be 3 over 2. So it's a 1.5. Now I will use this pivot to force both 5 and 15 to be zeros once more.
Negative 5.
Okay, yes, exactly right. Multiplying in negative 5. Negative 5 plus 5.
0.
Negative 5 and 3 over 2, it's going to be negative 7.5. Negative 7.5 plus 9, so you will have 1.5. Of course, these numbers are not going to change because those numbers are zeros in a similar manner. Multiplying 1 by negative 15 and adding the result to positive 15. Negative 15 times 0 plus 1, 1. Negative 15, 0 and 0, 0. Negative 15 plus 15 is going to be 0. Negative 15 in 1.5, I believe it's going to be negative 22.5. Negative 22.5 plus 23, so the result will be
0.5.
Stop. Let's do the rank and let's do the solution. First of all, for the solution issue, remark that this is the column of x1, that's the column of x2, that's the column of x3. So it's an x1, x2, and x3. Now, 1 times x1, it's going to be x1. 0 times x2 is 0. 0 times x3 is 0, which means x1 equal to 0.5. Similar manner, we let to x2 equal to 1.5 and x3 equal to another 1.5. That's the only solution that will make this equation is correct, the second correct, the third is correct. If you change this value to be half, 1.5, 1.5, let's do it. 2 times half, it's going to be 1. Negative 1 times 1.5 is going to be minus 1.5. So the addition is negative half. 3 times 1.5 is 4.5. Minus half is going to be 4, exactly like the number on the right hand side. And so on for the results. So that's the only solution. If you want to go through ranks, لو انت عايز تشوف الكلاسيفيكيشن بتاع الرانك تعال خليك معايا. The smaller matrix, which is the coefficient matrix, the rank of A is equal to
3.
those are 3 non-zero rows. يبقى 3. طيب الرانك مستر احمد بتاع الماتريكس از هول كلها على بعضها. كلها على بعضها الرانك ده 1 2 3. يبقى الكلام ده بيساوي الرانك بتاع الاوجمنتد ماتريكس، الماتريكس كلها على بعضها. وبرده النمبر اوف فاريبلز بيساوي كام؟ يبقى اللي عندي دلوقتي عباره عن consistent ماشي in dependent solution. This is a consistent system and it will lead to just only one solution, okay? Which is 0.5, 1.5, 1.5, and that's it. This is how to solve a system of equation using the general row operations. Any questions? Any questions? You will have to do it on your own. More than once. It is recorded. So try to do it more than once. Okay? Just to perfect the steps and how to go through it one by one. تمام شباب؟ حلو قوي. عمر خدت بالك ان الرانك بتاع الماتريكس الصغيره
3.
هي الرانك بتاعت الماتريكس الكبيره هي النمبر اوف فاريبل، صح يا شباب؟ وان انا النفع اجيب يونت ماتريكس. اوكي. Let's see another system. انا همسح ده عشان ادخل سيستم تاني. اوكي خلاص تمام 100 100. Let's do this system. Okay, I need to solve this system. So I will write it once more and we will solve it together. يلا مليني كده السيستم ده كده، السيستم اللي هناك ده.
1.
ها. It's gonna be 1,
3, 2.
3, 2, and the negative 1. Then I will have 2 صح؟ negative 1 بعدين negative 2 بعدين negative 1. Then I will have negative 1 بعدين 2 بعدين positive 3 بعدين 1. That's the coefficient matrix and it is equal to 3, 1, 2 and negative 1. Let's review it once more. 1, 2, negative 1, 3. 3, negative 1, 2, and 1. 2, negative 2, positive 3, and 2. Negative 1, positive 1, and negative 1. And that's the matrix which is 4 equations in 3 unknowns. Let's try to solve them together and to see what's going to be. I'm going to follow the same steps. The first element in the first row, it is already positive 1. So the first row is correct. 1, 2, negative 1, and the result equal to 3. I will use this pivot, which is positive 1, to force the elements beneath it to be zeros. معايا يا أحمد? So I will multiply 1 by negative 3 and add negative 3 plus 3 is equal to 0. Negative 3 times 2, negative 6 plus negative 1, negative 7. Negative 3 times negative 1 positive 3 plus 2 is going to be a 5. Negative 3 times 3, negative 9 plus 1, so it's going to come up to negative 8. Please be careful with me. I've multiplied the first row negative 3 and added it on the second row. Similar manner, Muhammad, I will multiply the first row in negative 2 and add it on positive 2. Negative 2 plus 2, it's going to be 0. Negative 4 plus negative 2, it's going to be negative 6. Negative 2 times negative 1, positive 2. Plus 3, so it's going to come up to 5. Negative 2 times 3 is going to be negative 6. Plus 2, so it's going to come up to negative 4. In a similar manner, Omar, I will need this number to be 0. So simply, I will add them together.
Positive 1.
1 plus negative 1, 0. 2 plus negative 1 is positive 1. Negative 1 plus 1 is going to be 0. 3 plus negative 1 is going to be 2. I've succeeded in completing the quest of the first column. I'm going now to move to the second column. I need this element to be positive 1. Any ideas? Any ideas؟
يبقى كام يا دكتور؟
ها؟
يبقى بوست 1
اعمل ايه؟
هضرب 8 في الرول اللي تحت خالص.
اضرب 8 في الرول اللي تحته اجمعه عليه. Very good. او اقدر to switch them if you like. ماشي؟
بس
To
أنا كده
take
لو
the fourth row instead of the third row. بس انا هعمل زي ما محمد قال.
بس انا يا دكتور لو عملت له سويتش فانا لما نزلت تحت هضطر اظبطه برضه. فانا كده
طبعا
الاحسن اللي هو اظبطه من الاول وخلاص.
ولا اروع. Multiply the last row by positive 8 and add it on the second row. انا هسمع كلامك. طبعا كلهم صح. All of them are correct. So multiplying the last row by 8 and adding on the second row. 8 times 0, 0 and 0. 8 plus negative 7 is gonna be
1.
8 times 0 plus 5 is gonna be 5. 8 times 2, 16. Minus 8, so the result will be positive 8. Now I've succeeded in getting the pivot of the second row. I will use it, this one, to force these numbers to be zeros. I will multiply by negative 2 and add on the first row. Negative 2 times 0 plus 1, it's 1. Negative 2 plus 2, it's 0. Negative 2 times 5, negative 10. Plus negative 1, it's negative 11. Negative 2 times 8, negative 16. Plus 3, it's negative 13. I will continue. Mr. Ahmed. I will multiply in positive 6 and add. 6 times 0, it's gonna be 0. Plus 0, 0. 6 plus negative 6, it's gonna be 0. 6 times 5, it's gonna be 30. Plus 5, so it's gonna come up to 35. Then 6 times 8, it's gonna be 48. 48 negative 4, it's gonna be 44. Am I right? The last row is 1, 0. Also, I need it to be 0. So I will multiply negative 1 and add. Negative 1 plus 1, it's gonna be 0. Negative 5 plus 0, so it's gonna come up to negative 5. Negative 5 times 8, negative 40 plus 2, so it's gonna come up to negative 38. Here is the numbers. So I multiply this row in negative 1 and add it on the last row. أنا آسف الرقم ده عكيتك. Negative 1 plus 1 is 0, negative 5 plus 0, negative 8 plus 2, so it's gonna come up to negative 6. كده adjusting the second row. I will go for the third row. Okay, the third row, I will need to change this 35 to equal to 1. So all I have to do is to divide this row on 35 or to multiply 1 over 35. Let's do it. So it's gonna be 0, 0, 1. Then I will have 44 over 35. Any problems? Okay. I will use this guy to continue my problem. So I will multiply negative 5 and add it on the second row. Multiply in positive 11 and add it on the first row. There will be no problems. But I will do the beneath row first. Multiplying in 5. 5 times 1 plus negative 5, so it will be 5 times 44 over 35. I believe it's going to be 44 over 7. Am I right? Minus 6 over, okay, minus 6. Minus 6, it means if I have a common denominator, so it's going to be negative 42. So the result will be 2 over 7. Am I correct? Am I correct? معايا Mr. Ahmed? I don't care about these numbers. I will stop. I don't care. Let's remark. Those rows are going to exist. So this one is going to be 0, 1, whatever the number, 5 and 8. That one is 1, 0, negative 11, negative 13. Let's talk about the ranks and to talk about equations. If this is x1, x2, and x3, let's try to expand them as an equations. فك كده. 1 times x1 Okay, I'm sorry, I'm talking about the last row. 0 times x1 is gonna be 0. 0 times x2, 0. 0 times x3 is 0. And it's supposed to equal to 2 over 7. Is this possible? So it is impossible to have this relation. So there is no solution for this system. مفيش حل للسيستم. لأن الايكويشنز اللي عندك are non-linear. So once you try to solve them, you ended up having 0 equal 2 over 7. If I want to talk ranks, by rank, the rank of the smaller matrix is rank of A is equal to 3. But the rank of the overall matrix is 4. The rank بتاع augmented بيساوي 4. They are not equal to each other, though there is no solution. In this case, we saw the n consistent case. I have 4 equations and 3 unknowns. One of them is not correct. It leads to one side is equal to 0, the other side is 2 over 7. The ranks are not equal to each other, so there is no solution. Okay, شباب؟ أي مشاكل؟ Okay, let's do the third system. I will erase it and you already have it recorded so you can regain it, and please try to resolve it once more. Of course, once you try to resolve it, if you change the rows or anything, it's going to be the same numbers, but you will end up having the same result exactly.
دكتور معلش بس عندي سؤال.
اتفضل.
هو كان في ارقام فوق احنا ما كملناش احنا ظبطنا.
مش تفرق معايا.
عشان في 3 زيروهات تحت صح؟
عشان في الماتريكس الصغيره 3 زيروهات وبعد كده الكبيره مش بتساوي 0. فما فيش معنى. عارف لو كان الرقم الاخير ده بزيرو كنت كملت.
تمام فهمت حضرتك.
اوكي. تعالى برضو بص تاني. The last system which is system number 3. حد يمليني system number 3. اوكي. once more عشان نحله تاني مع بعض. اهو 2 negative 1 and negative 1.
-5.
Negative 5, yes. Okay, 3 positive 4 negative 2. اللي بعديه 2 3 and negative 1. Am I right? 2 3 and the negative 1. 2 3 and the negative 1. And for those numbers we have negative 1, 2 and 4. And then this system is equal to 2, 1 and 3. Let's do it together.
Negatives together.
Okay? Negative 3, I'm sorry. Yep, 2, 3, 2, 2, 3, 2, negative 1, 2. Negative 1, 4, 3, 2, and 1. Negative 5, negative 2, negative 1, and 4. Okay? Once more. Let's try to adjust this system. خلينا نمشي نعدي نظبط السيستم ده. So it will lead to. I will need positive 2 to equal to positive 1. So what to do? I think we can add the second row on the first row. If we added the second row on the first row, ايه اللي هيظهر عندي؟ So negative 1 plus 2, it's positive 1. 4 plus 3, it's gonna be 7. 3 plus 2, it's gonna be a 5. 2 plus negative 1 is gonna be 1. 1 plus 2 is gonna be 3. Then I will use this pivot to force these two numbers to be zeros. So it's really very simple. All I have to do is to add 1 plus negative 1 is gonna be 0. 7 plus 4 is gonna be 11. 5 plus 3 is gonna be 8. 1 plus 2 is gonna be 3. 3 plus 1 is gonna be 4. Similar manner, I need this value to equal to 0. So I will multiply in 5, then add it. 5 plus negative 5, it's gonna be 0. 5 times 7, 37. With negative 2, it's gonna be 33. Okay, 5 times 5 is 25. Minus 1, it's gonna be a 24. 5 plus 4, so it's gonna come up to 9. 5 times 3 is 15. minus 3, so it's gonna come up to 12. Now I will need to adjust the second row. But before adjusting the second row, it just came into my mind that the second and the third row are almost the same. The second row, if you multiply it in 3 or negative 3 and add it on the last row, it will be erased, all of this. It will be all the elements will be 0. So I will do this first. Here we go. Multiplying second row by negative 3 and adding it on the last row. Negative 3 times 0 plus 0, it's 0. Negative 3 times 11, negative 33. Plus 33, the result is 0. Negative 3 times 8, negative 24. Plus 24, the result will be 0. Negative 3 times 3, negative 9. Plus 9, the result will be 0. Negative 3 times 4, negative 12. Plus 12, so the result will be 0. So the last row, it's all zeros. Continue. I will need this number to be positive 1.
No.
So I will have to multiply n 1 over 11. So it's gonna be 1, it's gonna be 0, then positive 1, then 8 over 11, then 3 over 11, 4 over 11. I have divided on 11 or multiplied 1 over 11. Then I will multiply in 7, negative 7, and add on the first row. Negative 7 times 0 plus 1, 1. Negative 7 plus 7 is going to be 0. Negative 7 times 8 over 11, I believe it's going to be negative 56 over 11. Plus 77, so let's do it step by step. Multiplying in negative 7, it's going to be negative 56 over 11. Plus 55 over 11, which is 5. The result will be minus 1 over 11. I will repeat it. Multiplying in negative 7, so it's going to be negative 21 over 11. Then I will add it on 1, which is 11 over 11. That means this guy is going to be negative 10 over 11. Do it once more. I will multiply in negative 7, so it's going to be negative 28 over 11. Then I will add it on 3, which is 73 over 11. Which means the sum will be 5 over 11. Am I correct? Okay, perfect. There is nothing else you can do. Look to this matrix, which is on the reduced echelon form. Look to this reduced echelon form. This reduced echelon form, you will have a unit matrix, as you can see, and this row is zeros, and you can't do anything else. Okay, let's talk ranks first.